talk about maintenance today and what that means. Meaning,
interesting subject for sure.
Yeah. When you buy a piece of equipment, no matter what it is, you should be getting a manual with it. And that manual should contain the maintenance recommendations. So when we go farther down our list on the maintenance topic today, we'll be referring back to that. But that's a key thing. Have the documentation, understand the documentation in regards to what gets maintained and what intervals. Now, that's the recommendations from the manufacturer. It doesn't mean that you can't do it at a different interval. You may determine that as you own the product, but that's the recommendation that you should always pay attention to.
Yeah, so it's good to be aware of that and make sure you're at least following the minimums there. Obviously,
Right.
More maintenance is no bad thing, but it's a good place to start with a manual.
Right. What we'll get into is the types of maintenance and I'll reflect back to something that maybe everybody can understand. So when you talk about the intervals, I don't want to get too sidetracked, but we're back on the manual thing, is when you buy your car, it recommends a certain interval you change your air cleaner, but it also recommends that if you live in dustier climates or dustier conditions, you should change it more frequently. It's no different than dynamometers or any other piece of equipment. So let's talk about the types of
maintenance.
Yeah.
So in terms of definitions of how we look at maintenance.
Right.
I think this is one where I think perhaps starting at the reactive side of that is these sort of the least involved, the one where we just wait for something to go wrong.
Right. So it's the three types, the three main types, because if you study it and you do your research, there's variations of these three types, which is reactive, which you spoke to just now, Chris. You've got your preventive, and you've got your predictive. If you look at reactive, it's the most costly, potentially, because you're waiting for something to fail. You're waiting for something to happen before you do something. It's also the highest in risk because you don't have control over what could happen, and you're not doing anything to really prevent it from happening.
Okay, so reactive is just basically running the machine, ignoring maintenance, and let's see what breaks, and then we'll fix it.
That's right.
That can be done with a car as well, usually with equally bad results there as well. But it is a way that some people operate, and they'd be happy to just to run it until something happens.
Right, and it's definitely not our recommendation is that you do reactive maintenance because, again, it goes against all the things we spoke about of the impact of waiting for something to go wrong.
Well, it appears like a low-cost alternative because there's nothing to do. But it's going to cost you more in the long term because there's going to be failures that then take a lot more to repair.
Very key point, Chris, because you just mentioned it. Short term, long term.
Yeah.
Short term seems good. Long term, it never works out. It lands up being more costly in the long term, and it lands up being higher risk from a safety perspective because now you're in no control over what can happen and when it can happen. The only thing you hope to have is monitoring to see things like temperatures and pressures as an indicator in your test cell. But if you don't have that, you're really asking for trouble.
So let's move to the more proactive side of maintenance. And I guess preventative is the next area where we can start to look at when we expect things may happen.
So now you're talking about a schedule.
Yeah.
You're talking about something that's fixed, that at these intervals, whether they be hours of operation or calendar days or months, it's a fixed schedule. So now you've taken the next step down the maintenance path to being more preventative. And you've got a set schedule. So now it should be less costly in comparison with reactive. And it should be definitely a more planned event to occur on a certain interval.
Right, and if they use the test bed, if you're relying on your test bed, then it's better to move to a preventative approach because then you can schedule when things happen. We can decide when you're going to be out of service and make sure that's to suit you rather than waiting for something to go wrong.
Right.
So I think I can see the advantage of preventative.
So one would say, what's wrong with that? Well, there's nothing wrong with it. It's just a way of doing it. But if you want to take the next step, in my mind, is that you go to a predictive type of schedule. So that's the cool part when you go to predictive, because now you're utilizing sensors to look at how your dynamometer is performing, and you're literally, per the definition, you're predicting when things could go wrong.
So tell me about the sensors then.
So if you're looking at, say, for example, temperatures on bearings or even vibration levels on bearings, you're looking at the trends. You're looking at when this dyno is operating, when you first put it in operation, you have a baseline set of data that you're looking at. And you're saying, okay, this is what it looks like when it's new. And then you're setting target values and it may be even building algorithms to look at the data real time as the dyno is running and predict when you think it's going to need to be changed or serviced.
So you need to build up a database on this really before you can get too advanced with it. Otherwise you don't have anything. If you see a change in vibration, you could say, okay, does that mean I need to start changing something? Or is this just the normal wear and we need to wait for to be predictive? How far do you go before you make a change?
Right. The science of this is basically you want to work with the OEM. The OEM should know their product better than anybody else. So they can help in determining what's the criteria for determining whether something needs to be maintained or something needs to be replaced based upon the data that you're seeing. We have vibration limits in fruit that we spec out that this is when you need to be concerned, what we call a yellow limit, and this is when you need to shut down because something is going wrong. What we want to do is with predictive is you want to actually see what's happening or make changes before it even goes yellow. You want to say, okay, this is trending in the wrong direction. It hasn't hit yellow yet, but this is the opportunity, knowing that it takes 6 months to get bearings or 4 weeks to get bearings, to plan appropriately to change the bearings in a advantageous time frame.
And I guess that could give you a window of changing circumstance where you can say, okay, we should be looking at doing this now, but with this level of change, we could wait a month.
Right.
And therefore give yourself some flexibility in when you could take your test, when you take the test bed down to do this.
Right. And then add this into the mix. We mentioned vibration. Now add in temperatures to the bearings. Now you have multiple sensors coming in to tell you the health and the status of a particular item on your dynamometer, like the bearings.
And best monitor any changes that are occurring and how quickly they're occurring.
Right. And then even more powerful, you're looking at the running conditions of the dynamometer. You're looking at, how long has it been at 100% load? How long has it been at 50% load? So you can get different parts of the equation to add into the bearing lifespan and the longevity of the dynamometer. Right. It's back to longevity.
So we've looked at what types of maintenance. What should we talk about? What is maintained? Just covering the reactive maintenance. What are some of the problems you might see if you pursue the reactive approach and wait until there's a failure? What would we see first?
It's an array of things. I mean, you may see dynamometers that have overheated. You may see dynamometers that have built up deposits. When I say deposits, calcium deposits, because either of the water quality or the temperature in which it was running at. If it runs too hot, you'll build up deposits quicker. You'll see the lack of lubrication resulting in failure modes on a dynamometer, whether it be a failed bearing, even a failed flywheel. So we sell flywheels at Fruit as well. So similar scenarios where you could have failed flywheels. Those two things, the cooling and the lubrication issues that come up, have different effects and impacts dependent upon the extent of the condition in which it's failing that determine that. You can have catastrophic. You can have half couplings that are sheared off the end of a rotor shaft or a hub, as they say, that have failed due to...
So what would we see if a bearing, you mentioned earlier about bearings potentially seizing, what would a bearing seizure show us?
It could be, the symptoms can come up as, if you're monitoring vibration, you'll see a change in vibration. It could come up as a bearing temperature that is gradually or increasing over time and not getting cooler again, not stabilizing, just the continued trend of going up and up and up. Those are two main ones. The inability to control based upon water temperature because you have a plug filter. The carcass temperatures are rising because you have improper flow. Those are some of the simpler ones.
So we want to move on to what is actually maintained. When we talk about the maintenance, we're looking at any of these types of maintenance. There's still certain things would have to be changed. So do you want to talk a little about the key areas of change when we maintain the product?
Sure. And again, these are generalities. What I would point you back to is the owner's manual or the operations manual, where it should tell you what particular components get maintained at what intervals. So always reflect back to the OEM product manual. But overall, you can expect to be maintaining on dynamometers, bearings, filters, seals, rubber components, if you're working with water brake dynamometers, and even some of the other dynamometers may have control valves that need to be serviced and maintained. Delivery systems for lubrication. All of them have some form of lubrication, obviously, and they need to be maintained as well, whether they're pump delivery, whether they're fed by air as a mist system, oil jet. There's different means of lubricating bearings, and again, it's just dependent upon the product or the dyno that you own.
Okay, but just rolling back to the bearing, excuse the pun. There are some which can be maintained, have some service, some maintenance activities that can extend the life of the bearing. Is that typically something that's done, or would you find the bearings would more often be replaced if the machine's been taken down?
Typically, dependent upon the dynamometer in most circumstances, if you have to replace the bearings in the dynamometer, send it back to the OEM if you have the opportunity and the chance to do that. Now, I can say I've been in both situations where I had the opportunity to do it, but I've also had the supplier come on site. It cost more, but I didn't have a choice. I didn't have the time to ship it back and wait for it to return.
But to address that, there are also sort of regional centres, service centres that are authorised to carry out this work, and that can be a more local source that could help you.
Right. First and foremost is to go with the OEM.
Yeah.
If the OEM is not a choice or not available or whatever reason you can't use the OEM, go with somebody that frequently services that piece of equipment that you have. They have a track record and they've done it before. But again, I would always go back to the OEM when possible.
Agreed. That's why we set up the Authorized Service Centers to try and address that when geographically it's a challenge to return the machine. But fundamentally, that's the best solution at any point.
That is an advantage of the food product of having the service centers that are certified. Most of the time, you're having to go with somebody else that's not necessarily certified. It's just somebody that rebuilds dynamometers, and they may have rebuilt one or two of them. But going with a service center that's certified by Frood really gives a confidence feel for that you've got the right people working on your equipment.
Yeah, and also make sure that when any parts are replaced, they're replaced with genuine original equipment parts, and we're not looking at introducing some foreign part that might just not have the life we expect.
Right, and one other key point is, and then we didn't... it wasn't part of this agenda, but it fits right in, is when you do maintenance with Frood, we keep the history. We know what's happened from it from day one, from manufacture, and we track its history, its maintenance report. If you work with us on it, we have the complete history behind that dynamometer.
Right.
Sometimes even if it's changed hands along the way.
Yeah, that's a very good point, and it's a good for the longevity side to have that history.
Mm-hmm.
So we've talked about the machines in sort of continuous use and fully operational and what maintenance you do. But there are also some machines which are used in an intermittent fashion. There are some which have to be stored for an extended period. So what's the maintenance requirement to protect those machines under those use conditions?
So another good question, because normally that's not discussed, and sometimes you may see that in an owner's manual and sometimes you may not. The key thing is with any rotating devices is there's a lot of things that go into play when you put this thing into intermittent use. And intermittent use is kind of a subjective thing because for some manufacturers that may mean 1 month, it may mean 6 months. But if you're not using the dyno for an extended amount of times, there are things you should be doing to it. If it's no longer in the test cell, you definitely should be preventing it from corroding, coating it with some spray or some liquid that prevents it from corroding. You need to make sure that the bearings, typically you're rotating the bearings at certain intervals to make sure burnelling doesn't occur. There are things and steps that you should take to make sure that when you do use the dynamometer again, it's the way that you left it when you first pulled it out of the test cell. It's in the same condition to put it back in again. So you need to consult with the manufacturer if it's not in the owner's manual for their recommendations. But I just listed a couple quick ones in regards to things that we would definitely want to make sure happens.
Yeah, no, it's very good description. Thank you. Having described all these maintenance stages, we move on to the how to do this. There are some situations where you might want to do this work yourself, but we recommend you refer this back to the original manufacturer, either through going back to the factory or use one of the authorized service centers.
There are certain things like that you can do yourself, just like an automobile. You can check the oil level in your own vehicle. You're not going to pay somebody to check the oil level in your car. Like a dynamometer, you're going to make sure your oil levels are maintained. You're going to make sure that the filters are clean. There's some simpler maintenance tasks that you should be able to do yourself if you choose to, but you don't have to. You can do the complete maintenance package with companies like Frood that are the OEMs. So, the nice thing about that is Frood maintains the records for the customer. So we'll have the complete maintenance records for it, and you don't have to worry about that part of it. With your maintenance program, if you elect to do most of it yourself, you've got to maintain those records. You got to make sure you got the history. You got to do a lot of things to properly do it. Not to say you can't, it's not impossible, but it's just the ease of doing it. Sometimes it's best to go with the OEM.
Yeah. No, it's important to have it looked after in the way it was first built, and the manufacturer is going to be the one who knows that the best.
Yeah, it boils down to risk. It's an insurance policy. You go to the OEM, you've got a good insurance policy that equipment is properly maintained and it'll last as long as physically possible.
That's why we see these machines lasting many years.
There's dynamometers that we've gotten back that are 30 years old, and the customer maintained the dynamometer, at least the facilities around it, so the water quality was excellent. And you'd be hard-pressed to look on the inside of that dynamometer and say that it looks 30 years old.
That's a good point, yeah. All right. Yep. We've talked about reactive and waiting until something fails. Does there come a point in that way of servicing where the machine really isn't worth fixing? The damage is such that repairing it isn't economical and we need to look at an alternative solution?
It sure would. I can tell you some of the dynamometers we've gotten back, you can tell which are maintained and which are not maintained. And when we get through doing the inspection, if you see a lot of corrosion, a lot of wear on the main components, it creeps up pretty quickly on the cost to repair it versus to buy a new one.
So it can get to the stage where not only is it not being reliable and accurate, but it's actually becoming dangerous and need to be replaced.
Yep, it falls back into the safety factor.
Yeah.
But again, it's the rotating components that can become quite expensive, especially if there's metal-to-metal contact, something's touching or rubbing against something. It'll get catastrophic very quickly. If not just being expensive, now you've got safety factors or safety concerns.
So a really bad example of bearing wear that would allow metal-to-metal contact within the rotating assembly.
Mm-hmm.
And at that point, things get dangerous.
But I would keep in mind how fast things can change if you don't do maintenance. You almost procrastinate and you talk about, I'm going to do it next week when we're coming down, when we really needed to do it 2 weeks before that. And something's lurking in the background that you may not be monitoring it. It never fails to any of the lab managers I've ever spoke with that have incurred a problem. It's always in retrospect, it's always easy to say, we should have did this or we should have did that. Maintenance may seem trivial. It may seem to some people too much money. But after you've experienced a catastrophic failure or you've had downtime in the test cell for 4 months because you couldn't get a part that failed because you failed to do the maintenance on it prior to it failing, the cost gets so extreme, so astronomical, it easily outweighs the decision to not spend the money and do the maintenance.
The routes to maintenance we talked about earlier would help you have the flexibility to pick a maintenance point when you want it with minimum disruption rather than waiting for something to go wrong and then having your cell out of action, as you say, for months potentially.
I can feel for the lab managers that have the constant pressures and push on them to produce data and runtime, uptime inside a test cell. I know every one of them probably are thinking, we need to bring this cell down, we need to do maintenance prior to something going wrong. I think most of them have the right intention to do that. I think the circumstances put them in handcuffs that they're operating under certain conditions because they maybe don't have the budget or whatever the case may be. Maybe it got cut, maybe the maintenance budget isn't as much as it used to be. Because people always wonder why, why did it fail? Why didn't we just spend the money and do this or do that? The pressures and the circumstances are wide and extreme, more than we have time in this podcast. But the best way to put it is it's disappointing sometimes when you hear some of the stories.
And hindsight's a wonderful way of looking back.
Yeah.
Okay. Thanks, Mike.
You're welcome.
Thank you for listening to Dyno Insights, presented by Frood. If there are any engine testing topics you'd like us to discuss, we'd love to hear from you. Please email us at podcast@frooddyno.com.